Welcome back to Train Signal. You are watching the video for Lab 3, controlling Intersite replication using site links and Bridgehead servers. We will be covering a lot of topics in this particular video. In particular, you will learn how to create and configure site links. Site links are physical connections between two sites. You will also learn how to create backup replication mechanism so that in case our default replication mechanism does not work, we have a backup way of replicating our domain controllers. You will also learn how to schedule the replication so that replication takes place during non-business hours. Then we will also optimize our sites by using what are known as bridgehead servers. We will further create what are known as site link bridges and connection objects. Even though these are optional, I will show you how they can be done. And finally, we will optimize our sites and domain even further by actually creating what is known as a global catalog and activating the feature which is new in Server 2003 known as the universal group caching. So let's get started. Let us see what we have accomplished so far and then determine where we need to go next. So here's what we have done up to this point. We have created two sites, California and North Carolina. We have created two subnets, 200.201.0 and 202.0, and then associated each of the subnets with the site. 201 is associated with the California site and 202 subnet is associated with the North Carolina site. Then what we also did was created a router so that there is traffic going through between the two sites. Finally, each of the sites has domain controllers. California site has two domain controllers, DC1 and DC2, and the North Carolina site has one domain controller, DC3. So we have accomplished replication at this point in our network, and the reason why we did all this, create sites, was to control two specific items. The first one of that is logon traffic, which we have already accomplished, and the second one is replication traffic. Let's revisit this topic one more time. Logon traffic. If you have a client in the North Carolina site, and this site has the 200.202.0 network ID, then what will happen is that when a user logs on to the network benandbrady.com in North Carolina, they will get authenticated by the domain controller DC3 and not by DC1 or DC2, simply because the domain controller in that particular site is DC3, and that is the domain controller that's authenticating them. So in this manner, you're controlling logon traffic. Your fast connection is within the same site, 100 megabits per second on the Ethernet cable, and your slower connection is between the two sites, which is the T1 cable or the T1 connection at 1.54 megabits per second. So when a user logs on, they will always get authenticated by the domain controller that is associated with that site, namely DC3. Their authentication packet will never ever cross over the WAN link to DC1 and DC or to DC2 to authenticate. So in this manner, you control the logon traffic. The second thing we need to do, and we're going to address that in this particular video, is to control the replication traffic. Now what is the replication traffic? If you recall, DC1, DC2 and DC3 are all domain controllers. In Windows NT, they used to follow a model known as a single master model. In a single master model, you had what is known as a Windows NT primary domain controller, PDC, and then the additional domain controllers were referred to as the backup domain controllers, or BDCs. The first machine, or the PDC, the primary domain controller, was the only read-write copy of the domain database. In other words, all the changes had to be made on the PDC. Once the changes were made to the PDC, then replication went from the PDC to all the other BDCs that were part of that domain. So once again, there was only one read-write copy of the database, and that was on the PDC. All the BDCs had a read-only copy. In other words, the changes went from the PDC to the BDC, or to more than one BDCs if there were more than one. In Server 2003, all this changed. The concept of Active Directory came about, and now you have what is known as a multi-master replication model. All the domain controllers starting with Server 2000, starting Windows Server 2000 are read-write copies or have read-write copies of the Active Directory. So for example, you can go to DC2 and create a new user object, and go to DC3 and create a new group object, and then put the user in DC2 that you created in user 2 I'm sorry, the user that you created in DC2 into the group that you created in DC3. So once again, the user is created in DC2, the group is created in DC3, replication will take place so that all the domain controllers are aware of all the objects, and you do not have one single point of failure like you did in Windows NT, where if the PDC failed, the BDCs were not able to create new objects. That is not true anymore. You can go to any of these domain controllers, and then create a new object, and multi-master replication will make sure that replication takes place between all three domain controllers, and you can basically have the same objects available at a very short time at all the three domain controllers. So the good thing is there is no single point of failure. If any of these domain controllers fails, there is enough information on the other domain controllers for your domain to be up and running. The drawback of this is that now there is more replication traffic, because before in the Windows NT PDC model, everything went from one to all the other domain controllers. Now each of the domain controllers can have their own changes, and the changes need to be replicated to all the other domain controllers in the domain. So we have an issue of a large number of replication objects or replication changes crossing over between domain controllers. However, fortunately for us, all this can be controlled, and this can be controlled if you create multiple sites and make sure that you have set up the mechanism in such a way so that replication goes through between certain domain controllers only, especially over the WAN link. So we're going to address all this in this particular video. So to summarize once again, one of the reasons why we created sites was to control two types of traffic. One is the log-on traffic, which we've already controlled, and the second thing that we're going to do in this video is to control what is known as the replication traffic. So let's get started with what replication traffic is and how it can be controlled. Let me take you back to my screen over here. There are two types of replication: intra-site replication, that is replication within the same site, and inter-site replication. Make sure you understand the difference between the two. Inter-site replication is replication between the two sites, and the words look very similar: intra, inter. So let's see what these two are. Intra-site or within the same site replication means the replication that is taking place between the domain controllers within the same site. So within the California site, you have two domain controllers, and the type of replication that DC1 and DC2 engage in is called intra-site replication. If you create an object in the Active Directory in either DC1 or in DC2, replication will make sure that both the domain controllers have the same object, and this kind of replication takes place within 15 minutes. So in other words, if you create a new user object over here on DC1, DC2 will get that user object the next time the replication goes through within 15 minutes. In other words, 15 minutes or sooner. Or if you want to push the replication, like I showed you before, let me show it to you one more time. You can also push it any time by actually going to Active Directory sites and services. So if you do not wait for replication to take place, what you do is, I'm going to go to DC1, and then on DC1, let's log in. We will go to Active Directory sites and services. So let's pick up that particular tool. And in Active Directory sites and services, if you ever want to replicate your domain immediately, you can always push it. So you basically go to the site. On that site, pick up the server, and here's the server. Click on the NTDS settings, and let's say that I would like to replicate between DC1 and DC2. So I'm going to pick up this connection object, right click, and say replicate now, and this will push the replication immediately. So you do not have to wait up to 15 minutes to see the user objects and other objects appear from one domain controller to another. So I'm going to minimize the screen over here and go back to our node over here. Intra-site replication is replication within the same site. It takes place within 15 minutes, or you can push it any time by using Active Directory sites and services. There is in fact nothing to configure in intra-site replication. All you have to do is make sure that the domain controllers are in the same site, and the knowledge consistency checker KCC makes sure that there is a ring topology for replication between DC1 and DC2, meaning that it will try its best to replicate between the domain controllers within the same site within 15 minutes. So that's all you need to do. That takes us to the next type of replication, which is inter-site replication. And this one is configurable, especially because the connection between the two sites is a slow WAN connection. So let's see how to do that. Here are the steps that you need to follow in order to control inter-site replication. The first thing we need to do is create what is known as a site link. Site links are physical connections between two sites. So there is one that is already created by default, And we can also create a backup site and then configure it. And that's the next step, configure the site link attributes. There are various ways of configuring the site link so that you can have, so to speak, a preferred site link. In other words, if there are two redundant paths between two sites, then you can choose which one the replication will take place first. So we'll talk about that. The next thing is to designate what is known as a preferred bridgehead server, so that when replication takes place between domain controllers in two sites, there are specifically assigned domain controllers that participate in the replication process. We'll talk about that also. Then we're going to create what is known as a site link bridge. This is optional for redundancy. And last but not the least, we will create what is known as connection objects. Once again, knowledge consistency checker has already configured these objects. This is optional in case you ever have to do it manually. So let's get started with creating a site link. I'm going to minimize this screen over here and then go back to DC1. Our connection is open over here, and we are in Active Directory sites and services. All replication and anything to do with two different sites is controlled by this tool known as Active Directory sites and services. So the first thing we need to do is talk about sites and how we can create the site links to control to control replication between the two sites. So here we go. If you recall, we had created two sites, California and North Carolina, and here are the domain controllers for each of the sites. So in site North Carolina, there's DC3, inside California, DC1 and DC2. So we've talked about extensively about the objects over here and then the objects over here. There is another item that's sitting out here called the Intersite transports. I'm going to expand that. And over here there are two different transport protocols, IP and SMTP. So we're going to talk about this in this particular video. So if I go to IP, you'll see that there is one site link that's already created, also known as a default site link, and then SMTP, there are none created. So let's talk about what an Intersite transport is. Here's what we're going to do next. These are the two sites, California and North Carolina, and you need a pipeline, so to speak, or a connection object that goes from California to North Carolina, which is known as a site link. So the site link is nothing but a physical connection between California and North Carolina. You'll be getting a T1 line from an ISP provider. That is a physical line. You have to put the attributes of that line in the Active Directory using sites and services. So that's what we're going to do next. Now, here is our site link. The site link is simply a physical connection. How the replication will take place from one location to another will depend on the transport mechanism or the transport protocol. In other words, site link is simply the physical pipeline, what goes through, or the mechanism that is used to actually communicate between one site to another that carries the replication packets will be a transport protocol. And there are two choices. The first choice is IP. This IP is basically nothing but RPC, or remote procedure calls, used over a TCP/IP network. So typically you will be using an IP network like we have done in our case, and then the default mechanism that is used is IP. It actually uses what are known as RPCs, or remote procedure call packets, over a TCP/IP link. And by default, Windows Server 2003 has created a site link known as the default IP site link. If you recall, a site was created automatically called a default first site name, and a link is created now called the default IP site link. We can of course change the name of this link to something else, and we're going to do that. So let's first select this and then right click on this and look at the properties of this default IP site link and see what we have in store. Here we go. This default IP site link is actually connecting the following sites. Here are the two sites that it is connecting, California and North Carolina. If you recall, we have just two sites. So the default IP site link automatically picked up our two sites and connected them together. In fact, if this were not the case, we would not be able to replicate between our domain controller in North Carolina, which is DC3, with the domain controllers DC1 and DC2 in California. So this was automatically done for us by Active Directory. So I'm going to close this. So this was the default name. It's a good idea to give it a more descriptive name. I'm going to right click on this and say rename, and let's call it California-North Carolina link. So this is our California to North Carolina link. I'm going to right click on it and go to properties, and let's see what else do we have in store. So the first thing that you configure about a site link is what sites it is configuring together. That makes sense. A site link is a physical connection object. Well, I need to know what two sites are being linked by this site link. So that is taken care of over here. Then there are three other things that we need to configure. The second one is the cost. The cost is simply a metric. so that you can choose which site link to use over the other. Let's take an example for this. Let's say that there were two mechanisms or two transport site links between California and North Carolina. Let's say you have a T1 line between California and North Carolina, and you also have a dial-up modem that connects the two servers between California and North Carolina. So T1, which runs at 1.54 megabits per second, is much faster than a dial-up modem, which you all are familiar, I'm sure, runs at 56 kilobits per second. So 56 kilobits per second versus 1.54 megabits per second. You always would like to replicate over, or rather, you would always prefer to use T1 line over the telephone modem line, which is 56K. So in order to communicate to the Active Directory, that always use T1. Unless T1 is down, then go ahead and use the telephone line, which is the 56 kilobits per second. And the way we communicate this is by means of the cost. The higher the cost, the chances are that the line will not be used, or the line will be used less. The lower the cost, the more chances are that the line will be used. In other words, if you have both the lines up and running, T1 and the 56K modem, between the two, if the both are up and running, the line with the lowest cost will always be used. Only if the line that has the lower cost is unavailable. For some reason, your T1 line is not available that day or that particular time when replication is scheduled to take place, then only will the modem be used. So once again, the lower the cost, the chances are better that that line will be used. This cost 100 is simply a metric. It does not signify anything. You can go all the way up to 9,999, in fact up to 99,999. Let's check that out. I'm just going to put 9s over here to see how far it goes. There we go, 99,999. So this is simply a metric for comparison purposes. In other words, if you designate T1 to be 100, then designate the modem line to be at 200, and in that manner T1 will always be used over the modem line. Then the next metric is what is known as replicate every. This is also known as replication frequency. This basically says how long should Active Directory wait before checking for updates. In other words, even though you have a T1 line that is always on, it's not going to replicate every second or every 15 minutes. It can if you replicate it as such. So by default, the value is 180, which is in minutes, so that is 3 hours. So it's going to check every 3 hours with the domain controller on the other side and determine if there is something that is waiting to be sent over to the other side. So in other words, the way to set up at this point for the T1 line, the domain controllers in California will check every 3 hours with the domain controllers in North Carolina and see if there are any changes. If there are, the changes will actually be sent through using the IP protocol mechanism. So that's a default frequency that is set up. You can set this up anywhere from 15 minutes, which will be the same amount of time for the intra-site or the replication within the same site, and you can set it up as high as 1 week. So in other words, if you would like to check for changes 1 week apart, you can do so as well. So far we've covered the cost, which basically determines what line will be used if there are more than one lines available. We've covered the replication frequency, meaning how often will the line be used, and last but not the least, you can also schedule the replication. So let's click on the schedule button over here. By default, it is scheduled to take place at any time. In other words, it will check every 3 hours, and then once the 3 hours is up, replication will take place. We can change all this, and we're going to do that in the next lab. So what I'm going to do is cancel this out, because we don't want to disturb our existing replication mechanism over here. I would like to keep it the way it is. What I would like to do is set up a new site link. So to do that, let's click on the IP over here. One of the things in this Active Directory sites and services you will notice is that it is very important to click in the right place before you right click, because only then will you see the right objects. So for example over here, once I click on IP and then I right click, I will see related objects that has to do with Intersite transports, namely site link and site link bridges. If I would like to create a new domain controller, I have to make sure I click over here and then right click, and then only will I be able to create a new server. If I would like to create a new site, I cannot do so by clicking over here, for example, right clicking and trying to create a new site. It's not possible. To create a new site, I have to go over here on the sites link, right click, and then say new site. Okay, so as you start using this tool more and more, you'll gain more and more familiarity with it. Let me give you another example. For example, I would like to replicate the directory changes between domain controllers. I cannot right click over here and then do that. If I do this over here, I'm going to go to all tasks, and all it says is move. I have to actually click on the NTDS settings and then go to one of these connections, right click, and then say replicate now. Okay, so keep it in mind. You will develop the familiarity with this tool the more you use it. But some of these things are pretty logical. I would like to create a new site. You have to click on this and then create a new site. I would like to create a new transport mechanism. You have to be in the right location. IP. I'm going to use IP as my transport mechanism and then create a new site link. So that's what we're going to do. So click on IP, right click, new site link, and now it wants to know the name of the site link. I'm going to call it backup ca-nc link. And by default, it picked up the two sites the two sites that we have, so that this particular link will link California and North Carolina sites. If not, I could have moved it from here to over here. But it was intuitive enough to know that there are just two sites, so those are the two sites that I would like to connect. And here's my new connection object. I'm sorry, here's my new site link. Now I'm going to right click on the site link and go to properties. So now we can differentiate between the first one and the second one. So by default, the cost is 100. Let's say my backup was the one for the modem. So what I'm going to do is over here increase this from 100 to 200. In other words, use T1. Only if T1 is not available, use this particular one. Replicate every. You can leave it the way it is, or if you want to increase the number of minutes over here, you can do so. Last but not the least, change schedule. What I would like to do is make sure that the replication takes place during non-business hours. So instead of saying replication at any time, I'm going to change the replication schedule over here. To do that, here's what you need to do. First you do is click on the all and then click on replication not available so that you clear the screen. Okay, so now you have a blank slate to work from. And then what you do is you select the hours during which replication can take place. So what I'm going to do is select from 12 midnight up to 8 over here, and then say replication available, and then again from 8 over here until 12 midnight and say replication available. So replication will not take place during the business hours of 8 until 8. Okay, so during the white band over here basically says that replication will not take place. Replication takes place only during non-business hours. And in this manner, you can also control exactly when the replication takes place so that too much traffic is not crossing your WAN link during business hours. The other thing you have to understand is that there are other kinds of traffic that is going to going through the T1 line during business hours. There will be resources that are on DC1 and DC2. Maybe there are printers and other items that users in North Carolina are actually accessing during the day at all times. For example, let's say the California site has the HR department, and the HR department maintains a server over here in the California site, and users over here need to access forms on a regular basis. So the users are actually going over the WAN link, over the T1 line and accessing the servers. If you have replication traffic going through during the same time, this will slow down the process of users getting resources from one end to the other. So it's a good idea to actually set up replication during non-business hours. Going back over here, we've actually established a connection, and now we have two connections. The first one, which is a default connection, and the second one, which is going to be a backup. And the way we ensure that it's a backup is not by simply renaming it, by making sure that the cost is actually higher. And then we control the backup by making sure that it replicates every 5 hours, and changing the schedule so that replication takes place during non-business hours only. After all, this will be a slower process. So that should do it for site links. If we just close these boxes, and let's see where we are at this point in our lab step. So we have created a site link, and then we have configured the site link attributes. The next thing to do now is to designate what is known as a preferred Bridgehead server. So let's get started with that. Let us first understand what a preferred Bridgehead server is. So let's go back to our diagram over here, and you'll be able to appreciate why it is important to set up a Bridgehead server by looking at this figure. Let's say that a change in the Active Directory takes place on DC2. So on DC2, you have modified, let's say, the username and the password for a different user. The changes have taken place over here. Now DC2 should replicate these changes to all the other domain controllers. So one of the ways that DC2 can do that is by giving it to DC1 and then also giving it to DC3. All right. when and let's for a moment assume that DC2 first gives it to DC3 and then after a few minutes gives it to DC1. In fact, let's put values. Let's say that immediately when the changes took place on DC2, it replicated with DC3, let's say in 2 minutes, and DC3 now knows that, well, the username for, the password for the username John has changed. DC3 is aware of that, and so is DC2. DC1 is still not aware of that. And now let's say that instead of replication taking place from DC2 to DC1, it now takes place from DC3 to DC1. In other words, the replication schedule was such so that now DC3 is ready to replicate with DC1, and now DC3 is informing DC1 that, well, the password for the username John has changed. In other words, our replication traffic went as such. It went from DC2 to DC3 across the WAN connection, and then again from DC3 to DC1 across the WAN. So the replication crossed twice the WAN link. Now, obviously that is not the best mechanism. Wouldn't it be nice if DC2 was simply to communicate with DC1 because they are within the same site and replication is fast in that manner, and then DC1 were to replicate with DC3 so that the information crosses the WAN link only once. In fact, wouldn't it be nice if all the replication between the two sites were to cross the connection or the T1 line just once, so that you control the WAN traffic in that manner. And that's exactly what a bridgehead server is. A bridgehead server is a server in each site that participates in the replication process. So in other words, if DC1 and DC3 were to participate in the replication process together, then DC1 and DC3 would be designated as bridgehead servers. DC2 does not replicate with DC3, and hence DC2 is not a bridgehead server. Bridgehead servers are important so that your replication traffic crosses the WAN link only once. The idea is that once the replication has taken place between the sites, then all the domain controllers within the same site can find out about the new changes to the Active Directory by means of intra-site replication. So let's see how to designate servers in our environment as bridgehead servers. So looking at this picture over here, what we are going to do is designate DC1 and DC3 as bridgehead servers. In order to do that, we need to use Active Directory sites and services. So let's go back to DC1. Here I am on DC1, and like I mentioned before, it is very important to click in the right place. So let's see if logically we can determine how to actually use this tool to create a bridgehead server. What I would like to do is designate a domain controller DC1 as a bridgehead server. So what I need to do is find the computer object for the domain controller DC1, and that is located under California, under servers, and here's DC1. Once I find that computer object, I'm going to right click on it and then go to properties, and over here is where I designate it as a bridgehead server. It is not absolutely clear how it works, but here's how it goes. Transports available for Intersite data transfer. So this is, in other words, what protocol would you like to use for Intersite data transfer? In our case, we're going to use IP. And then over here, if I actually click on IP and then click on the add button, IP moves from here to here. And if you read this column over here, it says that this server is a preferred bridgehead server for the following transports, IP. And now we're going to click on the OK button. Basically what this means is that you have just designated DC1, going back over here, as the preferred bridgehead server for the site California, and this bridgehead server is going to use the transport mechanism IP for inter-site replication. So in the California site, we have designated DC1 as a preferred bridgehead server. DC2, let's right click over there and make sure it is not a bridgehead server, and it is not. So let's let it remain the way it is. So now replication between DC2 and DC1 will only take place. We got to do the same thing on the North Carolina site. So let's expand servers, click on DC3, right click, and let me just reposition this, go to properties, and then over here once again click on IP, click on the add button, so that apply OK, so that DC3 now becomes a bridgehead server in North Carolina. So now the way the replication will take place is DC1 and DC2 will replicate with each other. DC1 and DC3 will replicate with each other across a site, and within the site, DC1 and DC2 are going to replicate with each other. Let's go into a little bit more detail about exactly how this replication takes place, especially those of you who plan to appear for the MCAC exams. Sometimes they want to know precisely in the manner in which the replication will take place between domain controllers when you have more than one site. So let's go through the mechanism by which this replication is actually going to take place. In the first scenario, let us assume that you have created a new user on the domain controller DC1, which is the Bridgehead server for California. So DC1 will inform its replication partners, and DC1's replication partners are DC2 and DC3, DC2 Intersite and DC3 Intersite. So DC1 informs DC2 and DC3 that, well, I have changes for you. Please remember, in Windows environment, everything is self-serve. There is no pushing, it's always pulling. They prefer to use pull technology at all times. Once again, DC1 does not push the changes to DC2 and to DC3. It simply informs DC2 and DC3 that, you know what, I have changes, come over and take it. So DC2 will then, through intra-site replication within 15 minutes, go to DC1 and pull the changes from DC1 to DC2. DC3 will do the same thing through inter-site replication. In other words, whenever the next replication was scheduled, 3 hours or during certain times, if you have set up a replication schedule, it will follow that schedule, and at that time check whether any changes are on DC1, and if so, pull the changes from DC1 to DC3. So again, the key point being, DC1 informs DC2 and DC3, and then the changes are pulled by DC2 and DC3 from DC1. Alright, so that was an example where the change took place on DC1. Now, just for practice and for review, let's also go through DC2 and see how these changes take place. Also, always notice that the replication will cross the WAN link only once, like I did in the previous example. Now let's assume that you've created a new group on DC2. DC2 will inform that I have something new to DC1 as well as to DC1 only, because it is not a replication partner of DC3. So DC2 will inform DC1 I got changes. DC1 will actually contact DC2 then and then pull those changes. DC1 then informs DC3 that I have new changes that you may not be aware of. DC3 then pulls the information from DC1 and then gets the changes in this manner. So once again, to review, DC2 only informs DC1 I have changes. DC1 updates itself. DC1 then informs DC3, and then DC3 pulls the information from DC1. Alrighty, and the last one is DC3 now, which will be very similar to DC1. DC3 has a change. Let's say that you have changed somebody's password on DC3. DC3 has only one replication partner, which is DC1. So DC3 is going to inform DC1 that come over and take a change. And this information will go through once again when the intersite replication is on. At that time, DC1 will say, okay, fine, give me the changes. So DC1 is going to pull the changes from DC3. So in other words, DC3 informs DC1, and then DC1 is pulling the change from DC3 onto DC1. Then DC1 has a change. DC2 is still not aware of the password being changed. So DC1 informs DC2, I have updated information in the Active Directory database, and the DC2 comes over and pulls the information off from DC1. So once again, if you notice that, just like you noticed, the information crossed the WAN link only once. The only way that Microsoft can make it more complicated in the exam is by adding more sites and more domain controllers to each site. But if you follow the mechanism, making sure that changes are pulled, the domain controller that has the changes simply informs the other domain controllers, which are its replication partners. And if you make sure that the replication partners are viewed correctly, for example, if DC1 and DC3 are Bridgehead servers, those are the two replication partners for DC3. And DC1 will only replicate with DC2 and with DC3, but DC2 does not replicate with DC3 directly. So if you keep in mind these little changes that take place, it sounds a mouthful, it sounds complicated, but if you follow the mechanism, it really is a very standard and streamlined way of replicating information between domain controllers. So that should finish our next point also, which is designating a preferred Bridgehead server, which brings us to the optional concept of creating site link bridges. Now this is no big a deal. Site links are, if you have more than one path. Let's take another example. Now we have two locations only, California and North Carolina. Let's say you had a third site, Illinois, and all the three are linked to each other. In other words, there's a link between California to North Carolina to Illinois, and then Illinois to California. What a site link bridge is that if the replication cannot take place one way, it will try to find another path and make sure that a replication takes place through that bridge. So for example, let's say that the connection between California and North Carolina breaks down over here. What the site link bridge will do is it will take the location in Illinois, which is, I know, not listed over here, but I'm just trying to point over here. The replication between California and North Carolina will take place in this manner. North Carolina to Illinois, Illinois to California, and then back over here from California to Illinois, and Illinois to North Carolina. In this manner, whatever California changes were in California is now also in North Carolina, and vice versa. So it's a way of redundantly finding a path, or sort of a bridge. In other words, if this does not take place, let's make a bridge this way and then this way, and make sure that the changes that could not go through this way actually goes there. This is the same concept that we use on a daily basis. If the expressway is jammed up, we take the side streets and make sure we get to our destination. So to create a site link bridge, you need to perform the following steps. What you do is you click on the Intersite transports link over here, and then select IP, because you're creating a site link for IP. Right click on it and say new site link bridge, and then automatically it will select all the links within this bridge. Remember, it's a bridge, so it has to select links. When you create a site, it will select your sites, or the two locations, California and North Carolina. Since this is a bridge, it's going to collect the links that you already have created before. So let's select these two, and once these two are selected, then all you have to do is click on the OK button and then proceed ahead. I'm going to give it a name over here. I'm going to call it backup bridge, and then click on OK. And that's all there is to it. So now you have a backup bridge between those two locations as well. So you have one link, which is a default link. This is the backup link, and then you also have a bridge, which is useful if you have redundancy within your network. So let's minimize this now and go back to the next topic of discussion, which is creating and configuring connection objects. Again, this is optional. This is already done by you for you by what is known as KCC, Knowledge Consistency Checker. Let's review this one more time. I touched upon this topic before, and in fact I had informed you that it's a good idea not to create one. When you expand DC1 and click on the NTDS settings, these are the connection objects that were automatically created between DC1 and these domain controllers. In fact, it's a good idea that these are created automatically by the server once you have created the sites and moved the domain controllers in the right sites. However, if for some reason, if you would like to create your own connection object, you simply right click on this and say new Active Directory connection, and then over here you going to go down the list over here. You want to just reposition this Windows a little bit. Over here it says select a domain controller from the list below by either site or name. So I'm going to select this particular one, and then click on OK over here. And it says there's already a connection from the source to the destination server. Would you like to create another one? I'm going to say yes. And then what do you want to call it? I'm going to call it a backup object. I'm just creating it to show you how it can be done, and it is done at this point. Okay. Please remember that knowledge consistency checker will not take into account this particular object when it tries to find the best path or a redundant path between domain controllers. So this is in case knowledge consistency checker for some reason, if you think that it has not done a good job, you can create an object yourself. Or for some reason, let's take an example, and this happens from time to time. And again, if it does happen, like I've mentioned before, I would rather spend a lot of time troubleshooting rather than just doing it directly. If you notice one more thing, since we made DC1 a Bridgehead server, did you notice over here, before we had in DC2 connection to both DC1 as well as DC3. That connection is gone now. However, if you go to DC1 over here, you will see that this is the one that I just created, but look at the other two. DC1 can replicate with DC2 as well as DC3. So I thought that would be of interest to you. So going back over here, so if you want, you can create a connection object. So for some reason, if you go to DC2 over here, and then you find that a connection object is not created between DC2 and DC1, well, go ahead and create one. Okay, so for example over here, you can create a connection object between DC2 and DC3 because one does not exist over here. Once again, I do not recommend that because knowledge consistency checker correctly identified to us that DC2 should only be replicating between DC1 and not with DC3. So leave it the way it is, but if you would like to create a new one, simply right click on this and say new Active Directory connection, and go ahead and create a connection for this particular domain controller. Also remember that each of these connection objects links the other domain controller only. So the way you read this is the following. I am on DC1 and I'm looking at the automatically generated connection object for DC3 and it says from server. So if I right click on this and say replicate now, and the replication is now scheduled for between sites, click on OK over here. What I've done is replicated from DC3 to DC1. Once again, if I were to click on this one, I'm on DC2 now, and I selected the connection object for DC2. If I right click and say replicate now, it's replicating from DC1 to DC2. It is a one-way process. If you would like to go the other way from DC1 to DC2, then you go over here and then you would pick up this one. Alright, and this will go from DC2 to DC3. I'm sorry, from DC2 to DC1 and so forth. So please remember that replication again is one way. It goes exactly the way you want. And later on in these videos, I'll be showing you how to create a script or a batch file using commands, so that once you save the batch file on your desktop, all you have to do is double click on it and replication will take place between all the domain controllers in your domain. So that's going to be pretty cool, and that video is coming up soon. That should also conclude the discussion in this particular topic. Let's go up and see what else we have in store for us. Let's summarize what we have done so far. We have created and configured site links. We have created a backup replication mechanism by creating a backup site link. We scheduled the Intersite replication. We optimized the site link also by creating what is known as Bridgehead servers. I also showed you how to create site link bridges and connection objects. So then the last topic would be creating what is known as global catalog and universal group caching server. So let's get started with that. Let us now begin with the global catalog. So let me change documents over here. A global catalog is simply a central database of information about all objects, all Active Directory objects in a tree or a forest. So let me explain a little bit about what this means. When you created your first domain, in our example, we created a domain called benandbrady.com. That is also a new domain, a new tree, and a new forest. Let's say that benandbrady.com now grows and branches out into Europe and Canada as well. So you may have three child domains for Ben and Brady. So underneath benandbrady.com, you could create three child domains. One would be usa.benandbrady.com. The second domain would be canada.benandbrady.com, and the third would be europe.benandbrady.com. So you have a total of 4 domains: the parent domain Ben and Brady, and the 3 child domains Europe, USA, and Canada. Now the global catalog, by the way, all these 4 domains will be part of the same tree. In fact, the fact that they are parent and child domains means that they are a tree, and there is only one forest at this point. So this global catalog server, or a computer or a domain controller that you designate as a global catalog server, will have the central database of information about Active Directory objects of the entire tree or the forest. It's going to keep the information for that whole tree. It will have just about everything it needs to know about that particular domain in which the global catalog is hosted, and what it does is it keeps a partial copy. So that's the next topic over here. The global catalog server stores a full copy of all objects in the directory for its host domain, and a partial copy of all objects for all other domains in a forest. So in other words, if you have a domain controller, in our case DC1, as a domain controller in the domain benandbrady.com, it will keep a copy of all the objects of the domain benandbrady.com. However, it will have partial or referral information about the other domains, namely Europe, Canada, and USA. So in this manner, the global catalog serves as a referential point or as a reference point, so that if it does not have the information, it can actually get the information for you. Let me give you an analogy for this. I'm sure you have visited the public library system. You go there and you're requesting a book. If the book is not available, the librarian or you can look at the database of books that they have and search for the book. If the book is not in that library, at least you will find out the information as to what library that particular book is available at, and now you have choices. You can either reserve the book at that library, physically go over there and pick it up, or you can have that book delivered to you. Well, over here in the global catalog, there is no physical going from one domain to another. What the global catalog does is that when the user requests some information, it first searches in its own catalog and sees if it can find the information. If the information is not there, it will try to make it will do a query in the other global catalog servers in the other domains and then get the information from there. So over a period of time, what happens is that you have replication between domain controllers, and then each domain will have their own global catalog, and you'll have replication going through between those global catalog servers as well. So there's a lot of replication, a lot of different types of information crossing over between servers within the sites. And that is why it is so important to make sure that we have certain computers configured to provide certain services so for efficiency to take place in our network. So going back to this, a global catalog simply is a central database. It stores all the information about the domain that it is currently residing in, and it stores partial information about other domains in the same forest. The biggest advantage of the global catalog is that the searches go by very quickly. You will search your own global catalog. If it has the information, it will provide it for you. If it does not have the information, it will get the information for you without actually going unnecessarily to many domain controllers before it finds it. And by default, you must have at least one domain controller in your site or in the forest. And by default, the first domain controller automatically became the global catalog server. So let me show you how to create a global catalog server if you don't have one. But before we do that, let's first talk about the design issue over here. Typically, it is nice to have a global catalog in each site so that all the computers in that site poll or query that global catalog within that site rather than go out. So for example, there's a user in the North Carolina site, and this person is trying to find a printer object in the Active Directory. When they perform a search over here, the global catalog, if one is created on DC3, will actually provide the answer. They will not cross over the link to DC1 to find the answers to the queries that they have. So the biggest advantage of a global catalog is it makes the queries or the searches go faster because it is a global catalog. It is a catalog, it has the information of all the objects in its own domain and a partial replica or partial information about objects in the other domain. And as far as how many global catalog servers you create, it is highly recommended that each location or each site has at least one domain controller, and at least one domain controller on each site is a global catalog server. Actually, having two global catalog servers in the same site provides no useful purpose unless, of course, if you have so many clients in one site that you may need two global catalogs just so that the searches go faster. So in our case, what we're going to do is the following. We will go and observe that DC1 is already a global catalog. It should be, but we'll verify that. And then what we will do is configure DC3 to be a global catalog server as well. So let's see how to do that. Once again, we'll have to go to DC1. So I'm going to connect to DC1 at this time. And then for all these kinds of activities, we of course use Active Directory sites and services. So we are in sites and services. And once again, following the same logic, what I would like to do is make the server a global catalog. So in order to do that, you need to click on DC1 and then click on the NTDS settings over here, right click and then go to properties, and right here is a checkbox, global catalog. And since we were on the DC1 computer object, it is already configured as a global catalog server for us. So I'm going to click on the OK button over here. Once again, just to make sure you understand that clearly, this is where the confusion sometimes lies. And again, it's not a big deal. All you do is if it's not over here, you go somewhere else and find it. However, to create a Bridgehead server, if you recall, we had clicked on DC1, right click properties, and that's that's how you created the Bridgehead server for the IP transport protocol. To create a global catalog, do not click on that. Click on the NTDS settings, right click, go to properties, and then you'll see the checkbox for the global catalog. You want to cancel this out. Now let's see if we can do the same thing for DC3, which will be a global catalog for the site North Carolina. So I'm going to expand DC3, I'm going to expand North Carolina, expand servers, and then expand DC3. Click on this, right click, properties, and there we go. It is not a global catalog. We just started a new replication schedule over here for global catalog. Click on OK, and then we're done. So from now on, there will be two kinds of replication traffic that is going through between DC1 and DC3. One would be the the Active Directory replication traffic, and the other one would be the global catalog traffic as well. So the global catalogs on the two would be updated, and the searches will go faster on each of the locations because the users on each location will look up for the global catalog on DC3, and the users on the California location will look for the global catalog on DC1. The other note about global catalog also is that is the fact that in Server 2003 and in Server Windows 2000 Server as well, there was a new group called the Universal Group. Universal Group took away all the restrictions that were there for other types of groups such as local and global. You can put any resource in any universal group. You can put any user from any domain into the universal group. You can put any group, or you can put any group within the universal group, and so forth. The global catalog is the one that keeps information about universal group membership within it. So in other words, when users log on and they need universal group membership information, make sure that the global catalog is available. Otherwise, your log on will take a long time, simply because the users have to go on the other side of the WAN link to find the global catalog before they can log in. So keep this in mind. That is also the reason why they say that it is a good idea not to create users directly within the universal group. Once again, let me repeat that. Try not to create users within the universal group. The reason for that is that if you have 100 users within the universal group, all those 100 users now have to be replicated between the global catalog servers of the two locations. It is a good idea to create groups first and then put those groups into the universal group. So let me give you an example. Let's say that there are 100 users, and those 100 users need to be put into a universal group called finance universal group. Alright, so it's a good idea to actually create a group first. So what you can do is create a group called global finance group, and put all the users within the global finance group, and then put the global finance group into the universal group. In this way, universal group has just one object known as the global finance group, rather than 100 user objects within it, and the replication will actually go faster. This is also very popular and a common exam in the MCSE questions. So we have successfully created DC1 and DC3 as global catalog servers. So I'm going to minimize this and then go back to our last topic of this particular video, which is, let's go back to the topic, which is the universal group caching server. Universal group caching is a new feature in Server 2003. Once again, this feature was not in Server 2000. Here's how universal group caching works. Like we discussed in the last topic, that when you log in, the information about universal group membership of the user is provided by the global catalog. And in our case, we had DC1 and DC3 set up as global catalogs. Now let's take an example where, for example, at one of the locations, you do not want to have a global catalog, simply because the replication lines are slow. You can only have a T1 line, you cannot have a T1 line rather going through over there, or the replication traffic becomes so heavy that the line cannot keep up, simply because you have too much information crossing over between those two sites. So there may be cases where it is not feasible to have a global catalog server at each site. And this was getting the case with Server 2000, where they had to set up global catalogs at each locations, and the links between two locations may not be good, and then whenever replication took place, everything slowed down everything came to a standstill, and it just was not an efficient process. So what Microsoft has done is that with the new Server 2003, they came out with an improvement, a new feature called universal group caching. And that's how this works. This is useful only if you do not have a global catalog at a location. So first let me show you how to activate it, and then I'll show you how the domain is going to benefit using universal group caching server. So let's first go back to DC1, and now I'm going to use Active Directory sites and services one more time. And now we will set a universal group caching server on DC3. So let's assume that DC3 is not a global catalog server. I know we just activated it, but let's assume that at the North Carolina site, we do not want to set up a global catalog. So what we would like to do instead is create what is known as the universal group caching server. What we need to do for that is, and again, this mechanism over here is slightly different. If you recall, we went to NTDS settings of the domain controller to set up the global catalog, and that's how we did it. Okay. Now, what you need to do is the following. You need to click on the site object, which is NC, and then on the right hand side, go to the NTDS site settings. So once again, click on this and then go over here. I'm going to review this one more time. There are three different checkboxes that you need to find, and I'm going to quickly show you once again how to use those checkboxes. So you first click on the North Carolina site, and then right click on the NTDS site settings in the details pane over here, and then go to properties. Then right over here is a checkbox for enable universal group membership caching. You click on this, And then by default, you can leave this the refresh cache for default. It can come from anywhere, or you can specify exactly where you want this to come from. So you can say California, for example. And then you can also set up a schedule. Once the caching is done, you can also set up a schedule, and I'm going to explain all this to you. But if you would like to set up a schedule over here, you click on the change schedule button, and these buttons work a little bit differently. For example, this key over here, the guide over here says that this means once per hour. So if you see one little square filled up in this rectangle, it means once per hour. And in this manner, if you have the entire square filled up, it will be 4 times per hour. So this is taking place every once every hour. So the replication will take place once every hour in this particular mechanism. And then finally click on, get my checkboxes, my OK button over here. Finally click on the OK button, and you've successfully set up DC3 as a universal caching server. Now let me explain to you what that is. I'm going to minimize this, and let's go back to our network diagram over here. Okay, here we go. Once you set DC3 as a universal group membership caching server, the next time the user logs on to the network, to the benandbrady.com network, what DC3 will do is, because it's a universal group caching server, it will contact the global catalog on the other side and get the universal group membership information and store it permanently on DC3, hence the word caching. So once again, DC3 at this point does not have the global membership information for a user. So the first time the user logs on, it will actually contact the global catalog, obtain that information, and keep it in its cache permanently. This cache can be updated by means of the replication schedule that we just saw every 15 minutes and so forth. So that now every time the user logs on, even though there is no global catalog, the user gets all the group membership, universal group membership that it needs from the universal global caching server over here. And in this manner, you've avoided the need for a global catalog. Mind you, the global catalog does more than just universal group membership caching. That was just one of the features of the global catalog. The global catalog also makes the searches go faster, so that it can look up objects in domains that is not directly a member of. So you may still need a global catalog, but if for some reason you do not, at least for login process to go faster, the universal group membership caching server serves a good point of entry. So this finishes all the topics that I had planned for this particular video. We created and configured site links, we created backup replication mechanisms, we scheduled Intersite replication, we also put the cost on it if you recall, and the frequency. We optimized replication by using Bridgehead servers. Then I also showed you how to create site link bridges and connection objects, and last but not the least, I showed you how to create a global catalog server, and lastly the universal group caching server as well. Now going back to, before I stop this video, a couple of things I want to show you very quickly so that you're not lost in this particular tool. This tool is well designed, but at the same time the checkboxes are not consistent yet everywhere. So let's quickly go through a little drill over here. If you would like to create a new site, you simply click on Sites, right click, New, Site, and then you're done. Those of you familiar with DOS may be familiar that if you would like to create a directory, you have to be in the directory above to create a directory below it. So that's the kind of concept that works over here. Since I've clicked on the object called Sites, I'm actually creating sites underneath it. Now if you're working within the site, so I have to first go to the site and then expand it, and then I have a container over there called servers, expand it, and now if I would like to create a new server, you simply right click on it, new, and then server, and then you create a server object in this particular dialog box. Again, you may not have to do this because the server objects will be created automatically as you add additional domain controllers to your domain. Going further now, if you would like to make the server a global catalog, what you do is you select it, then you click on the NTDS settings. So once again, the global catalog has to do with Active Directory. That's how I remember these little things. So, and the Active Directory is controlled by what is known as the NTDS settings. If you recall, global catalog is nothing but a collection of, or a catalog of all the objects in a domain. So you got to click on the NTDS settings box over here, right click, properties, and that's where you'll find the checkbox for the global catalog. So that is accomplished. One more thing, to create a Bridgehead server. Now you're creating a Bridgehead server on the server object, not on the NTDS settings. So you click on it, you right click on it, properties, and then you move the IP transport mechanism from here to here to create what is known as the Bridgehead server. So that took care of global catalog, Bridgehead server, and last but not the least is a universal group membership caching server For that, you need to go to the site object. And now this time, on the right hand side in the details pane, go to the NTDS site settings, right click properties, and there we go. You have the checkbox over here. Click on the checkbox, and then you would have enabled DC1 as the universal group caching server for the site California. Remember, you need a caching server for each site. Last but not the least, the transport mechanisms are under the intersite transports. There are two of them, IP and SMTP. SMTP is for backward compatibility. This sort of sends out exchange type packets. IP is the preferred protocol that is used over IP networks, and we always use this for our replication mechanism, for our replication transportation. Last but not the least, the subnets were created under the subnets link. So we have created two subnets. If you'd like to create a new subnet, you simply right click on it, new, create a new subnet. To associate the subnet with the site, you simply right click and then go to properties, and then over there we picked up the site with which this particular subnet was associated. So that finishes or rounds up all the activities that we need to perform in Active Directory sites and services. We had to go through an elaborate setup and go through several videos in order to accomplish what we have done so far. So just to summarize, this is what has happened so far in the benandbrady.com domain. benandbrady.com has two sites, California and North Carolina. The California site has two domain controllers, DC1 and DC2. North Carolina has one domain controller, DC3. What else? The subnet for California is 201.0, the subnet for North Carolina is 202.0, and we have associated the subnets with the sites. There are two Bridgehead servers, DC1 and DC3, and the replication traffic is crossing the WAN only between DC1 and DC3. DC3 is also set as the universal group caching server. We also have set up the global catalog on DC1 as well as on DC3. This concludes our video in controlling Intersite replication. I thank you very much for watching this video, and I hope to see you very soon in a different video in Active Directory.